morning, children. So welcome back to the online session of a mathematics class. So as we know that in the last session we had completed the exercise 4.2. So in today's session, the circles lesson, we will go for an example and I will solve the question from the question paper, previous year question paper. Then we will complete this lesson in today's session. Then from the next, from tomorrow onwards, we will discuss about the new lesson, that is construction. Okay. So before going to that lesson, we will complete this example and we will have an exercise, previous year example. We will discuss that one also. Okay. So now question is, let's take it now page number 101. We can refer this example 2. So two tangents TP and TQ are drawn to a circle with center O from the external point T. Prove that angle PTQ is equal to 2 times of OPQ. So there will be two tangents drawn to a circle with center O from the external point T. So I am having a circle. So let me write the circle. Okay. So with center O. So I will be having a external point P. Okay. External point T, and we have two tangents TP and TQ. So I'm having TP, then TQ. So this is T, P, and this is Q. Okay. So TP, TQ, and we need to do that PTQ. So PTQ, this angle will join O and P. Okay. Then OPQ. So we need to join PQ also. So OPQ. So this angle. Okay. So we need to prove that angle PTQ, this angle, equal to 2 times of this angle OPQ. This is OPQ, this angle. So this is 2 times of this. This angle is 2 times of this. We need to prove this from the question. So two tangents TP and TQ are drawn to the circle center O from the external point T. Prove that angle PTQ is equal to 2 times of OPQ. That we need to prove that. Okay. So we take write that we have given a circle center. We have given a circle with the center O and TP and TQ are tangent. Okay. Tangents to a circle with point of contact. So this is point of contact P and Q. Right. So this is given. Written that whatever figure I written that. I written the statement for that. We are given a circle, the center O, TP and TQ are the tangents to a circle with point of contact P and Q. These two are the point of contact. Okay. So now we need to prove that this angle is equal to 2 times of this angle, right? Let me take this as a T. Angle PTQ will take it as theta. Let angle PTQ we will take it as theta. Okay. So we will define this. What is the angle between these two tangents? We don't know that. In fact, we need to prove that that is equal to 2 times of OPQ. So therefore, I will define it as theta, some angle. Theta is some angle, whether it may be 30 degree, 40 degree, whatever it is, some angle. But it must be equal to 2 times of OPQ. Therefore, I am defining it as a theta. It has a theta. Okay. Now we will do one thing, right? So we know that TP and TQ are tangents from the external point T to the circle O. Therefore, TP must be equal to TQ, right? So we will write this. We know that. So otherwise we will write directly PT is equal to PQ in the bracket we can write tangents to a circle from point T, from external point T. So therefore those two must be equal because length of tangents from the external point to the circles are equal. They are 2. So PT is equal to PQ. So now assume now you know that if I am having a triangle Q. So this is the triangle and these two sides are equal. Right? Then we have learned from the class 9 that angles opposite to equal sides are equal. Angle opposite to equal sides are equal. These two sides are equal in the sense these two angles are equal. Because this is the angle opposite to this side and this is the angle opposite to this side. If these two sides are equal, angles opposite to equal sides are equal. We have learned that, right? Angles opposite to equal sides are equal in the class 9, right? So quadrilateral lesson, we have learned that, right? Now, since these two are equal, so I can write that what is that angle? TP and then TQ are equal, therefore these two angles must be equal. What is that? TPQ, then TQP. Right? Those two are equal. We write that angle TPQ is equal to TQP. So if you want, you can write angles opposite to equal sides. Equal sides are equal. So we have learned it. This is a theorem. So TPQ is equal to TQP. We will call it as equation 1. We will call it as equation 1. So TPQ is equal to angle TPQ is equal to TQP because angles opposite to equal sides are equal. Okay. Now in triangle TPQ we know that sum of all the interior angles will be equal to 180 degree. That is angles of property of a triangle. So if you add all these three angles, that must be equal to how much? 180 degree, right? So we will write that angle. We know that. Otherwise, in triangle. TPQ angle TPQ plus angle TPQ plus TQP plus PTQ will be equal to 180 degrees. Sum of all the interior angles. This and this and this. These three angles. Sum of these three angles must be 180 degree. The reason is angles of property of triangle. Angles of property of triangle AST. Okay. Now, so TPQ will write as it is TPQ. Then TQP. TQP can be written as TPQ from equation 1. So TQP can be written as TPQ because those two are equal from equation 1. So in the place of TQP, I can write TPQ, right? So PTQ I will write as theta, defined as theta. We will substitute that is equal to 180 degree. So TPQ I will write as it is. TQP is equal to TPQ angle TPQ. So I have substituted that angle PTQ I have defined as theta. I have substituted in the RHS 180 degree. Okay. Now, 2PQ plus TPQ, angle TPQ plus angle TPQ will become 2 times of angle TPQ. I will send theta to the other side, RHS. So 180, I am having 180 degree over there. If I send theta to the other side, it will become minus theta. Okay. So 2 TPQ is equal to 180 degree minus theta. Okay. So now, So we'll keep TPQ here only, angle TPQ, we'll send 2 to the other side. So since it is multiplied here, once it is transformed to the RHS, it will get divided. So angle TPQ is equal to 180 degree minus theta. We have in the RHS. So since 3 is multiplied, if you send to the other side, it will get divided. Okay. So 2 times of TPQ. Okay. We'll split the 2 denominator for both the terms. 180 degree divided by 2 minus theta by 2. Correct? I have split the denominator for both the values. Okay? So 2 ones are 2 90s are. Okay? So this is 90 degree minus theta by 2. In the LHS I have angle TPQ. Call this as equation 2. Call this as equation 2. So TPQ is equal to 90 degree minus theta by 2. Okay. So we'll write this whatever equation we are getting. Since so we have taken that PTQ, angle PTQ is equal to theta. Okay. Then what is that? TPQ is equal to 90 degree minus theta by 2. We'll write this because just keep on going. I'm going to write this. Okay. So that is what I'm writing over there. Whatever the derived equation you will be getting, I'll be writing over there. Okay. Now, since OP is the radius, TP is the tangent. So these two must be perpendicular to each other. Correct? From the theorem 1, tangent at any point of a circle is perpendicular to the radius through the point of contact. TP is the tangent, OP is the radius, both must be perpendicular to each other. That means this angle must be how much? 90 degree. What is that angle? TP, not Q. TPO, because O is the center. O is the center, OP is the radius. TPO will be 90 degree or OPT is 90 degree, whatever it may be. TPO or OPT. So we'll write OPT only. So we know that angle OPT is equal to 90 degree. In the bracket we can write TP is perpendicular to OP. Right? TP is perpendicular to OP, TP is the tangent, OP is the radius, both are perpendicular to each other. Okay? Now we know that if you want to find out this angle, so in the complete angle, so I need to subtract this. So OPT is the complete angle, this total angle. So if I want only this angle, so from the complete angle, I need to subtract this angle, right? I need to subtract this. What is that? So if you want to find out OPQ, from the complete angle OPT, you need to subtract TPQ. This angle I need to subtract it, correct? Then only I will get this angle, right? So we will write that. So from figure, so angle, what is that? OPQ can be written as angle, what is the complete angle? OPT minus, so this angle I need to subtract TPQ angle TPQ. Okay. Now we'll substitute the noun now. OPT and the OPT is 90 degree minus angle TPQ is 90 degree minus theta by 2 from equation 2. 90 degree minus theta by 2. Okay. Now this is equal to 90 degree. This minus, since I am having two terms, this minus should be split for both the terms. So minus into plus, minus 90 degree, minus into minus, plus theta by 2. Theta by 2. In the LHS I am having OPT. So in the RHS you know that plus 90 degree minus 90 degree will get cancelled. Okay. Plus 90 degree minus 90 degree will get cancelled. So what is remaining now? What is remaining? So in the LHS, angle OPT equal to RHS 90 degree minus 90 degree get cancelled. What is remaining? Theta by 2. Theta by 2. Okay. I will send 2 to the other side. It will get divided here. If you send to the LHS, it will get multiplied. Right? So this is 2 times of OPD. So what is theta? So theta is nothing but PTQ, angle PTQ. Angle PTQ. I have defined that. Right? So we will write LHS in RHS, RHS in LHS. Or angle PTQ is equal to 2 times of OPT. OP T, it's not the OPQ. So OPQ, this is OPQ. So this is also OPQ. This is also OPQ. This is also OPQ. Okay. So PTQ is equal to 2 times of OPQ. PTQ is equal to 2 times OPQ. That I need to prove that and prove this. Okay. Prove. Okay. So that's it. This is example 2. So we have example 3 also. Go through the example 3. If you have any doubts, get back in. Okay. This is example 2. So from the circles lesson, there will be one compulsory question. There will be one compulsory question will be there for the 3 marks. That compulsory question will be either out of those 2 theorems. There will be one theorem definitely. So it's a rare cases. They may ask out of these exercises. They may ask one question. It's a rare case. If they didn't ask those 2 theorems, then they may ask in these exercises. Okay. So probably 95% they will be going to ask between those 2 theorems only, either theorem 1 or theorem 2. So they will be asking between those 2 theorems only. You need to practice those 2 theorems. So there may be some chances of asking these questions also if they are not asking that theorems. But since the lessons are removed in this COVID situation, there will be a chances of asking more questions also from the circles if they have removed other lessons. Right? So better you can practice all the exercises and then theorems also. Right? Okay. Then we will go for question paper example and solve that. Okay. They have given AB and AC are the 2 tangents drawn from the external point A to the circle with center O. If angle BOC is 130 degree, find BAC. I will write the figure and you will understand that. There will be a circle with center O. Then they have tangents AB and AC. So this is okay. Then it's connected OB and okay. So this is O here, B, this is C. They have given that AC and BC are the tangents drawn from the external point C to the circle with center O. And they have given that this angle is how much? 130 degree. They have given that. The question is find this angle. Find if angle AOB is equal to 130 degree. Find angle ACB. So this is question 1. Find ACB. So this is question 1. We need to find out ACB. So I have done that. This is given, and this we need to find out that. Right? So by using the concept of quadrilateral, sum of angles of a quadrilateral. So this is one last question. It's very easy. Okay. So how will you find out this? You should find out B. Okay, you need to find out this angle, right? So you know that AC is the tangent, OA is the radius. That means both must be perpendicular to each other. Therefore, this angle must be 90 degree. BC is the tangent, OB is the radius. Both must be perpendicular to each other. Therefore, this angle is also must be 90 degree, right? So we need to find out this. We know that AOBC is the quadrilateral. AOBC is the quadrilateral. So we can write directly angle OAC plus OAC plus AOB. AOB. All the four angles must be equal to 360 degree. We know that angles of property of a quadrilateral is 360 degree. Sum of all the interior angles of a quadrilateral 360 degree. Sum of all the angles of a triangle 180 degree. So this is a quadrilateral, four sides. Therefore, sum of all the interior angles must be equal to 360 degree. So angle OAC, angle OAC is 90 degree. Correct? This is 90 degree. Plus ACB. ACB we need to find out. Let me write as it is. Then OBC, that is also 90 degree. Then AOB. AOB we have given that is 130 degree. This is equal to 360 degree. So add all the numericals, that means all the degrees, send it to other side. So 90 plus 90 will become 180. 180 plus 130. So 180, 280, 310, right? So ACB plus 310 is equal to 360, right? So angle ACB, keep ACB here only. Angle ACB 360 degree. Send 310 to the other side, it will become minus 310. So 360 minus 310 will become 50 degree. So angle ACB is 50 degree. So this is the required angle. This is one marks question. This is enough. No need to write the theory and all. This is enough. This is one marks question, right? All the angles is equal to 360 degree. You substitute the angles, find out the missing angle, right? So, okay. So these type of question they will be asking for one marks question or multiple choice question, and theorem will be asking for the 3 marks question. So probably in this year they may ask more questions from the circles. So be prepared. The entire lesson, whatever I have done it. Okay. So this will complete the circle lessons. So I will be going to conduct the test on Monday. Okay. So you will be having 2 days for the preparation. So I will be conducting a test, unit test on Monday on the circles lesson. So be prepared for the lesson. Then after Monday, from Tuesday, I am going to start with a new lesson, that is constructions. So it is the very easiest lesson, construction. So in the class 10. Which is the easiest lesson in the sense it is a construction. So it's very easy. They will be asking around 5 to 6 marks from the construction lesson. It's a very small chapter and it's very easy. Okay, so that's it for today's class. If you have any doubts in circle lesson, please get back to me. So thank you. We'll meet in the next video.